Hi friends, welcome back to Hobby Plus. Today I make a circuit for you that is a same ground circuit. You have so many problem with this ground. You already comment me in my last video and last 2-3 videos. First of all, I describe the circuit. Look at this. I make here a voltage regulator which is LM7805. That is your absolutely used for this Arduino control. In the market we get the same number of this IC, we get this, but there is a problem. This IC in this type cannot give you 5 volt output. It is 4.68, it is 4.7, it is 4.758, something like that. We can solve this problem. If you need exactly 5 volt from the output of this LM7805, then we can do one thing. We put here a pot. Something like that. We also connect this 2 pin with ground. Something like that. After that, this point connect to this point and remove this point. Then, oh sorry, there is a problem. Now you can adjust your ground pin through a resistance, that is a potentiometer. You just put here maybe 100 ohms. If that is your value, then you can easily control your output voltage to vary this potentiometer, and you can get 5 volt here. But one more thing, if you watch the data sheet of this 7805, in there you can find one thing: input voltage and output voltage difference is maximum 10 volt, but your source voltage is 24 and you try to get 5 volt from here, so that is 19 volt difference. In that case, you can do one thing. You can use a network resistance network circuit and you make 10 volt or 12 volt max, and you can solve this problem. Otherwise, your LM7805 goes to be hit. In that case, I have to tell you something. What is the purpose of this diode? LM317, LM338, we use this feedback diode, but in that case I also use this diode. You have to comment me in my comment box, and what is the purpose of this diode, you just tell me. That is a question for you, right? Now back to the main circuit. You want to isolate your Arduino from the output circuit. So that's why we make this circuit something like that. In last video I told you get here a 5 volt. You cannot drive the optocoupler through 5 volt. That is the maximum voltage is 3. So you have to put a resistance network here or Zener diode, whatever it is. Then you can drive the optocoupler easily. Second point is, when you drive the MOSFET by the optocoupler, the maximum voltage of this number is 80 volt. 80 volt can pass through this transistor, but 50 milliampere, the maximum current you can pass through this transistor. So you need a resistance network here. Carefully listen this part. That is your pulse. When it is off, that means collector and emitter in open condition. So your base gate can get maximum voltage of this network. Network output can maximum voltage. If you put this resistance top of the collector, then your transistor when off, your MOSFET get high voltage, and that is 24 volt. If your MOSFET gate source voltage plus minus 20, then your MOSFET goes to burned out. So carefully, if it is plus minus 30, then you have no problem. You can use it without resistance. But you have to use the resistance here because that is a high ampere voltage. So respect to this resistance, this MOSFET drop the voltage from the base gate of the transistor MOSFET, and you can use it. If not, if it is plus minus 20 volt, then you have to make this resistance network. Both are ground same, so put here. That is your pulse driving circuit. So your MOSFET goes to be on, and you can control your pulse from the Arduino, and your LED goes to be dim or deep. But one more thing, in that case I have to tell you something. I have a video in my channel that is LED driver circuit. That is nothing, that is the ampere control circuit. When you drive your LED through this circuit, you must put this driver circuit, ampere control circuit for this LED each and every time. That is a good habit, good practice for that. Otherwise your LED goes to be burned out. Be careful. You cannot replace the transformer with a optocoupler. I know you know that, because optocoupler ampere is very low, so you cannot drive the LED in high ampere. So you have to use this transformer here. Now the second and third part is, you want to measure your voltage. That is the important part. Definitely through Arduino you can measure your voltage from the output of this circuit. Now look at this. I have a question. Suppose that is your 5% on pulse, and in that position you get 1 volt. Can you get any voltage from the output of this optocoupler? That is my second question. If not, then how can you measure the one voltage which is come out from the output circuit? I think you have no way to do this, but you can tell me, you must tell me, or you please tell me, how can I measure the voltage V1, I mean 1 voltage from this output? And your maximum voltage is 24 minus zero point 0.2. Remember that is the internal loss of the MOSFET. Transistor collector to emitter forward bias loss is 0.2 volt. Never forget this. When you calculate your voltage, you must calculate the loss also. Now you tell me, how can I measure the lowest voltage? And one also, you get here a pulse. Yes, you think how it is, because I put here a pure DC 5 volt, and that is the ampere control resistance. It should also control your voltage, but you cannot get any other voltage. You get a pulse from this optocoupler. You can ask me why. I tell you, that is your input pulse. So optocoupler diode part also off and on, and you get the output pulse from this point. That means gate point. When gate is in pulse mode, that means sometime it is off, sometime it is on. So output voltage also get you same type of pulse, but more than 50 hertz, when pulses come throughout the MOSFET and LED goes to off and on again and again, but we cannot see this. We see this, the LED is continuously on. All we know that. So that is your 40 kilohertz, yeah, 50 kilohertz, 80 kilohertz, whatever it is, that is a pulse output also, which is through this LED goes to transformer to ground. That is your DC 24 sources ground, right? So you get here a pulse. When you get here a pulse, then you also get here a pulse. So your Arduino get pulse from the output of the circuit. Now you also tell me, how can I measure this voltage as a real value? I think you know that. Please comment me in my comment box. 3 questions I make here. One by one you should, or you please answer me. That answer also motivated me to make more video, and you know what to do. Please do this. Thank you for watching.